Okay everybody, so now we are at question 9. Question 9 should be rather simple, but let's take a look at the question. They say draw dot and cross diagrams for aluminium chloride and ammonia. So if we apply the rule again, aluminium has 3 valence electrons, chlorine has 7, 7, 7, so there will be 3 single bonds. So aluminium chloride should look like this. And your ammonia, NH3, nitrogen has 5 valence electrons, hydrogen has 7, 7, 7. So in this case also single bonds. So I'm just left with one lone pair of electrons. Okay, this should be easy to get. Okay, so 9b actually asks why these two molecules form an addition product when they react in the ratio 1:1. So of course the first thing would be to ask yourself, what do you mean by an addition product? Okay, these are the things that you need to think about when you interpret a question. Interpret the words, okay, decipher. Addition product means that it must come from a donor and an acceptor. Okay, and for a donor, what is its characteristic? What must it have? Okay, it must have lone pair of electrons. Okay, for an acceptor, okay, there are two different types. Acceptor number 1, what is this characteristic? Well, we know that one characteristic is that the central atom is electron deficient. Okay, another characteristic of an acceptor is that the atom has vacant orbitals to accept electrons. So based on these two criteria, we can decide out of these two molecules which one is the acceptor, which one is the donor. So in this case, very simple, we see that NH3 has one lone pair of electrons, so that means NH3 must be the donor. Whereas for aluminium, you notice it has 2, 4, 6 electrons. Okay, it has 6 electrons, which is actually short of an octet structure. So that means in this case it is electron deficient, and it actually fulfills my criteria 1. Central atom is electron deficient, so that means AlCl3 must be an acceptor. Okay, so in this case, you also need to think about why is it that they react in a ratio 1:1. Well, very simple. You saw that it was 6 electrons, just 2 electrons short of an octet, and just nice there are 2 electrons here. So I only need to have a reaction between 1 AlCl3 and 1 ammonia. Okay, that gives 1:1. So how do we, well, in this case, explain why it forms? So very simple, explain, which is actually just what we went through. So the first thing is, we need to mention that Al in AlCl3 is electron deficient, 2 electrons short of an octet. Take note, in the presentation of your answer, you need to have this exactly. It is the Al in the AlCl3 that is electron deficient. Okay, please take note of this part. You must have this. Okay, following from here, after this, and hence it is able to accept a lone pair of electrons from ammonia. And you must mention that it is through a dative bond from N atom to Al atom. So you notice in your answer, you talk about the electron division, and you also talk about being able to accept a lone pair from ammonia. Okay, and you also need to mention that there is a dative bond from N atom to Al atom. So as a summary, the key points needed are, number 1, you talk about the acceptor. Okay, then after that, the acceptor accept electrons from where? From the donor. Okay, and finally, you need to mention that the bond that is formed is a dative bond. So 3 key points in your answer. Okay, moving on from here, we look at part C. By considering the numbers of bonding and non-bonding electron pairs, draw diagrams to show the likely shapes of aluminium chloride, ammonia, and the product. So take note, you need to show the shape in your answer. This is the requirement given. And they say draw diagrams. Okay, so what do we mean by a diagram? Okay, you need to indicate clearly the value of the bond angles. So let's draw it together. Aluminium chloride, AlCl3. So we know 0 lone pair, 3 bond pair, so trigonoplanar 120 degrees. So you should have Al, in this case trigonoplanar, Cl, Cl, Cl. So you need to put in your lone pairs. Okay, and indicate clearly the value of the bond angles. The question asks you to do so. So this one should be 120 degrees. Okay, moving on to the next molecule, we have ammonia. So ammonia has 1 lone pair, 3 bond pair. So it should be trigonal pyramidal with 107 bond angle. So ammonia, trigonal planar with a lone pair. And the bond angle, please indicate it clearly. This is 107 degrees. And in this case, how do we draw the addition product? Okay, the addition product is important because you need to show the shape as well, okay, around the atom. So in this case, let's just try. This nitrogen lone pair will be donated into the aluminium atom. So what I can do is the Al, after reaction, it should have a tetrahedral structure because I have 1 bond pair, 2 bond pair, 3 bond pair, and 4 bond pair. So I should draw a tetrahedral structure, and this is a dative bond, okay, from nitrogen to ammonia. And you notice that nitrogen also have 4 bond pair because 1 bond pair, 2 bond pair, 3 bond pair, 4 bond pair. So again, it should be a tetrahedral shape. Okay, so you need to show this tetrahedral shape. Okay, and take note that in this case, your nitrogen is the one giving the electrons, so arrow should be pointing towards aluminium. Please do not put a lone pair here. Okay, you either show dot or you either show cross, but not both. And in this case, your chlorine, remember to put in the dots, and that is your addition product. Okay, and of course you need to show your bond angle. Since this nitrogen, it is tetrahedral, we should have 109.5 degrees, and with respect to this aluminium, it is also tetrahedral, so the bond angle is also 109.5. And take note of how you actually write it out. Tetrahedral about, or we say with respect to nitrogen atom and aluminium atom. Okay, that's how we say it. So you notice this aluminium has 4 bond pair, 0 lone pair. Similarly to this nitrogen, 4 bond pair, 0 lone pair. So that is how you draw your answer. Okay, finally, let's take a look at question 9D. So the question asks you to suggest the structural formula of the possible similar addition product from beryllium difluoride and ammonia. Similarly, for addition product, you also need to think about which molecule will be the donor, which molecule will be the acceptor. Of course, donor is easy to see, okay? Just look out for lone pairs, okay, on the central atom. So based on this, let's take a look. Beryllium difluoride, okay, sounds cheap, but it's actually very easy. Beryllium difluoride, because Be, di means 2, so BeF2. So let's take a look. Be is 2 valence electrons, fluorine 7 7. So this is simply just a single bond. So we should get this beryllium and F, single bond. 1 2 3 4 5 6, 1 2 3 4 5 6, and this beryllium has 2 bond pair, 0 lone pair, so actually it is a linear shape. Okay, and then for ammonia, very simple, NH3 with a lone pair. So of course, very obviously, NH3 must be the donor and beryllium must be the acceptor. Okay, and if you take note, beryllium central atom only has 2 electrons times 2 plus 2 electrons, 4 electrons. So this beryllium has 4 electrons. Actually, it is 4 electrons short of an octet. So if it is 4 electrons short of an octet, that means it will need how many pairs of electrons to gain octet? Well, it needs 2 pairs of electrons to gain octet. But you notice ammonia, one ammonia only has 1 lone pair, but it needs 2 lone pair. So therefore, I actually need 2 ammonia donors to react with it. Okay, so based on this, we can draw it easily. Let's take a look. I will draw it over here. Okay, so if you notice, this beryllium originally has only 2 bond pair. Now if I have another 2 ammonia donor reacting with it, it should have a total of 4 bond pair, and there is 0 lone pair. So that means it must be of a tetrahedral shape. So in my drawing, I must ensure that I have a tetrahedral shape. And I can put in my original fluorine. It doesn't matter where I put it. I can put it in this position, or I can put it in this position, okay? Or I can even put it in this position. It doesn't matter because all 4 positions of a regular tetrahedron is the same. So for simplicity's sake, I just put it next to each other. Remember to put in the electrons. Okay, and for ammonia, I can put it here and H3. Remember also to show tetrahedral with respect to the nitrogen atom, and I must show that it is a dative bond from nitrogen to beryllium. Similarly, for the another NH3, it is also a dative bond towards beryllium, and I must also show the tetrahedral shape. Okay, so in this case, this is just the structure of my final product. Okay, although in this case, question didn't ask you to draw bond angle, but just for being explicit, just put in 109.5. This is tetrahedral, okay, with respect to beryllium atom, okay, and also tetrahedral with respect to nitrogen atoms, to the 2 nitrogen atoms. So this one is 109.5, this one is also 109.5. Okay, so these words in orange, you don't need it. You only need the structure, but it will be good to know all this. I mean, in fact, you need to know all this.